Hi students, welcome back to my YouTube channel SADHIK Physics. So we started wave optics and we completed Huygens wave theory and interference. No, in that also in the previous video I discussed YDSE theory, right? So YDSE theory we discussed, no, and in this chapter so numericals we are going to discuss. So really, if you are coming for first time this video, no, please go through the YDSE experiment theory. Then afterwards come back, no, then only you will understand very clearly. So because what are the formulas we used, so what are the concepts we are explained, so you will understand very clearly now, right? So let us discuss this one now. So we'll go for I think just we will recollect it, no, what are the informations, no. So just quickly I will discuss, no. Therefore interference means what superposition of the two coherent waves, no. Therefore we calculated for phase difference for a constructive interference, no. Phase difference is nothing but 2n into pi. Clear? So 2n into pi, and path difference is nothing but n lambda, where n starts from 0, 1, 2, 3, so on. So destructive interference, no, I also just go through the interference concept also. So 2n minus 1 into pi. So therefore here path difference, no, we can write down 2n minus 1 into lambda by 2. So we already discussed. And amplitude also, so you know it, no, therefore root of a1 square plus a2 square plus 2a1 a2 cos phi. Strongly I suggest you please go through the interference and YDSE theory concept, no, then come back to this one, no, then only you can understand very clearly, right? If not, therefore it is very difficult to understand this. Please go through it, no. And also we discussed so therefore in YDSE experiment, no, we discussed, so the position of the fringes, no, can be written as d by d into delta. So we already discussed this one, no. So therefore delta you can substitute here now, therefore n lambda for constructive interference for bright bands, no, 2n minus 1 into lambda by 2. So for a destructive interference or dark fringes, no, right? And also we discussed the fringe width, no, therefore d lambda by d. And also we said that all the fringes are in the interference, no, will be in the same size, right? So intensity distribution we already discussed everything, no, just please go through it, no. And also therefore so beta, if it is considered in if it is performed in a one medium, so beta in air divided by its refractive index, no, so we can calculate it, no. Clear? Angular fringe width also we discussed. Angular fringe width is nothing but beta by d, or that is nothing but lambda by d, no. Clear? So this is your angular fringe width, no, therefore here. So I already still more clarity you can get it, no. Suggest you go through the theory compulsory first, then come back to this one, no, then we'll see one by one questions, no. Clear? So now let us see here, no. Therefore if you are not able to see the questions, no, please don't worry. So just concentrate on my words so that you can understand very clearly, no. Clear? So right. So therefore in YDSE two narrow slits, no. So two narrow slits are 1 mm apart, no. Therefore narrow slits are apart, no. Therefore small d is given as how much, no, 1 mm. Illuminated by the source of wavelength, no, wavelength is given as 500 nanometer. So 500 nanometer, therefore 5 into 10 to the power of minus 7 meters. So how far apart adjacent bright bands in the interference pattern is observed on the screen? So d is equals to 2 meters. So suppose any students know, therefore what is this statement? So how far is asking distance, no. Therefore apart adjacent bright bands are there, no. Adjacent bright band means what? One bright band and another consecutive bright band, no. That means indirectly is asking this is a fringe width, right? So therefore he is asking fringe width, no. Fringe width, what is the formula? D lambda by d. So D is how much now? 2 into 5 into 10 to the power of minus 7 divided by 10 to the power of minus 3. Clear? So therefore here 10, therefore taken 10 to the power of 4. So 10 to the power of 4 minus 3 minus 7 means 10 to the power of minus 3. So that is nothing but a 1 millimeter. So this is your fringe width. No? Also find the distance of third fringe from the center of the screen. Therefore third bright fringe is asking, no? Therefore third, no? Therefore 3 into d lambda by d, therefore that is nothing but 3 into beta. So 3 into 1 mm, therefore it is nothing but 3 mm will be the formula, will be the answer for this. Clear? So be careful, no, how these formulas we got it, no, because of due to the theory. So just go through the theory, then we can come to know this one. Let us see one more question, no. Right. Right. In the above question, find the distance of third dark fringe from the central maxima. Also find, okay, third dark fringe from the central maxima. So he is asking previous one, no, previous one what is asking, no, is asking from this one, no, third dark fringe. Third dark fringe means what you have to do now? Third dark fringe, no. So also above question, find the distance from the central maxima. So therefore here third, no, therefore here it is nothing but 2n minus 1 into, so d lambda by 2d. So this is your formula. So 2 into 3 minus 1 into 1 mm by 2. Why? Because d lambda by d is 1 mm. So this is how much now? This is 6 minus 1, therefore 5 by 2 into 1 mm, therefore 2.5 mm will be your answer. Third dark fringe. Clear? Also find the distance between the fourth dark fringe and sixth bright fringe. So therefore here is asking, no, therefore y sixth bright fringe, no, minus fourth dark fringe, no. Clear? So therefore here, so sixth bright fringe means what? 6 into d lambda by d minus fourth means, so 2 into 4 minus 1 into d lambda by 2d. Clear? So what I can write it now? Therefore 6 minus 8 minus of minus plus 1, sorry, so therefore here it will be, this is by, right, actually it is this you have to multiply by 2, divide by 2, no, therefore I can rewrite it as this one, no, therefore here d lambda by d, so this is 6 minus 2 into 4 divided by 2 minus of minus plus 1 by 2. Clear? So therefore here you will get cancel out, no. So this is 1 mm into 6 minus 4, it is nothing but 2 plus 1 by 2. So therefore it will be 5 by 2. So R 2.5 mm will be your answer. Clear? So therefore don't confuse anything, no, right? So now we'll go for another question, no. Right. In YDSE performed in twice, therefore 2 times is performing, no. So firstly with a wavelength, therefore with wavelength lambda 1 is how much now? 300 nanometer. Secondly with a wavelength of 500 nanometer. Clear? So find the minimum order of maximum of first experiment coincides with a maximum of another one, no. Sorry. Minimum order of maximum of first experiment, no, coincides with a, okay, d is given, d is, these all are values are given now. So therefore suppose here what is this question now? Suppose here there is a minimum order of the maximum of first experiment, no, first experiment that coincides with the maximum of another experiment. Suppose I am taking here, no, therefore some distance, no, this is one distance, due to one y1 distance, no, due to another one more y2 distance, no, this distance should be the same. So maxima of first experiment, no, and maxima of another experiment. So that means this distance should be the same for first experiment, this distance should be the same for the another experiment, no. So that means minimum order, that means with the first experiment what you are doing now, suppose here fifth bright band or fourth bright band or like that, no. Second experiment you are doing, no, like a third bright band or fourth bright band or fifth bright, anything you have to find it, order first of all, which one, no. So therefore you know that y1 and y2 both are same, no. So you know that maximus only, no, maximus means what, n into, okay, this is with this one, no, n order, this is nothing but a m order, okay, m into d lambda 1 by d is equals to m into, so d lambda 2 by d, these two get cancelled out, no. So n into 300 nanometer, it will be equal to m into 500 nanometer, so these get cancelled out, no. So 3n is equals to 5m. So when it will be takes place now, when it will be right, so what should be the value of n, what should be the value of m, so that it will be able to get equal onto this, no, minimum number, no. Therefore if I try 2, so n value is 2, therefore okay, so suppose I will take it as n value is 3, so m value is 2, so 3 3 is a 9, 5 2 is a 10, not possible, no, like that. So suppose I will take it as this is here 4 and this is here 3, I will take it, no, 4 3 is a 12, 3 5 is a 15, not possible, no, not equal, no. So like that you have to check it, no. So therefore minimum number is nothing but I can multiply with 5, I can multiply with 3. So therefore here 5 3 is a 15, 3 5 is a 15, it will be the same. Below that numbers, no, it is not making equal, no. So therefore when you are doing the experiment with the lambda 1, fifth bright band, so will be coincides with this side third bright band, clear. So therefore if you are doing with therefore with the first experiment fifth bright band and with the second experiment third bright band, no, they are going to coincides, clear. So in this way you have to identify it, no. Then is asking distance between the consecutive overlapping of maximas. So this distance is asking, no. So distance is same, no, therefore you can calculate either y1 or y2, you can calculate it, no, anything you can calculate because both will come, no. So y1 I will calculate it, no, y1 is nothing but a fifth d lambda by d, so 5 into d is how much, no, d is 1, lambda is nothing but a 300 nanometer 10 the power of minus 9 divided by 2 millimeter, 2 into 10 the power of minus 3. So therefore here 15 by 2 taken top note 10 the power of 5 into 10 the power of minus 4, so 7.5 into 10 the power of minus 4, so 0.75 mm will be the distance of overlapping, clear. So like this you should understand the concepts, no, so that you can do the problems very easily, clear. Now we will go for another experiment, another question. Right. So now in double slit experiment, now light has a frequency. So he is given as light of frequency is 6 into 10 the power of 14 hertz. So therefore here wavelength can be written as, so therefore C is equals to, so wavelength into frequency. So wavelength is equals to C by frequency. 3 into 10 the power of 8 by 6 into 10 the power of 14. So it is 1 by 2. 1 by 2 means 0.5 minus 14. So therefore I can take it as 1 here, no, 5 into 10 the power of minus 7 meters will be your wavelength. So the distance from the center of adjacent fringes. Okay. So in the first question I already discussed, no, the distance between the centers of adjacent bright fringes is 1 mm means what? This is what? This is nothing but a fringe width. So capital D is given as 2 meters. Now he is asking small d. You know it, right? Therefore, he gave d is equals to 2 meters. Find the distance between the slits. No. So simple question. So beta is equals to d lambda by d is equals to 1 mm 10 to the power of minus 3. So d is given as 2. So wavelength is given as 5 into 10 to the power of minus 7. So by d is equals to 10 to the power of minus 3. So this is 10 to the power of minus 4. D is equals to 10 to the power of minus 4 into 10 to the power of 3. Sorry, this is 10 to the power of minus 6 because 10 and 10 to the power of minus 6. So 10 to the power of down and top taken top no 10 to the power of minus 3. So therefore, what you can write it now here 10 to the power of minus 3 meters, that is nothing but a 1 millimeter. Clear? So the slits are separated by one small distance, no, that is 1 millimeter. Clear? Now we will go for another question, no? Right? Let us see one more question, no? Here. So the distance between the coherent sources is coherent sources. Therefore, he is given as D is given as 0.3 mm. The screen is placed at 90 centimeter. Clear? So the second dark band is about 0.3 centimeter away from the central bright fringe. Okay. So he is asking second from this one now. Second dark fringe. He gave the distance about 0.3 centimeter away from the center. Find the wavelength and the distance of the fourth. Okay, first of all, let us calculate the wavelength. No? So then the distance of fourth bright fringe from the central max. Okay, so first let us calculate the central max wavelength. No? So he gave this is your second dark fringe. So you know that y2 you can write down 2n minus 1 into d lambda by 2d. Clear? No? So this is given as 0.3 centimeter. No? So 0.3 into 10 to the power of minus 2. Clear? So 0.3 into 10 to the power of minus 2. 2 into 2 minus 1 into, so d is how much now? 90 centimeter. 10 to the power of minus 2. So wavelength divided by 2 into, so 0.3 into 10 to the power of minus 3. So you can simplify it, no? This is 10 to the power of minus 2. Minus 2 get cancelled out, no? So this is here, this is 3 into 10 to the power of minus 4. Okay, can write it as. So this is 4 minus 1. Therefore, here I will write it as 0.3 is equals to 3 into 90 into lambda divided by 2 into, so 3 into 10 to the power of minus 4. Clear? So therefore this 3 cancel here, no? Therefore here, so wavelength lambda can be written as taken here, no? 2 into 10 to the power of minus 4 into 0.3 divided by 90. Clear? So 3 into wavelength is given as 2 into 3 into 10 to the power of minus 5. So divided by, therefore 9 in t. Therefore 3 ones are 3 30s are. Clear? So 2 by 3 into 10 to the power of minus 6 meters. So this is your the wavelength which is used here. Clear? So 2 by 3 into 10 to the power of minus 6 now. Right? So I got the wavelength now. Therefore the distance of fourth bright fringe from the central maxima. So is asking. So fourth bright fringe now. Therefore y4 is equals to 4 into d lambda by d. 4 into d is how much no? D is nothing but a 90 centimeter, 90 into 10 the power of minus 2 into lambda is nothing but a 2 by 3 into 10 the power of minus 6. So D is given as how much no? 0.3 mm. 3 into 10 the power of minus 4. Clear? So 3 30s are 3 1s are 3 10s are. So this is 8. This is 8. 10 the power of minus 1. So 10 the power of minus 7 plus 4. 8 into 10 the power of minus 3 meters or 8 millimeter. Clear? So this is the distance of fourth bright fringe. Clear? Now we will go for one more question. Okay. Young's double slit experiment, one of the slit is painted, okay, one paint is there, no, so that the intensity of the light emitted from it is half of the light of emitted from the other slit. Therefore here the intensity is there, no. So from one slit, therefore here the intensity is I. So therefore here the intensity it will be nothing but a I by 2. Clear? So then which of the following statement is true? Fringe will disappear? No. Therefore here, so fringes will not disappear, no, fringes will be, this is wrong. So bright fringe will become more brighter and dark fringe will become darker. So bright fringe will not become more brighter. Why? Because initially it is coming out I and I. So actually what you can write it now, maximum I max it should be equal to 4 I naught and I minima should be equal to 0. Clear? So therefore here it cannot be become more brighter, no, bright fringes will not become like a brighter because here intensity is becoming decreased onto this one. Therefore this statement is wrong. So both bright and dark fringe now will becomes like a dark. Okay, let us see here, no. So first of all here what will be the I max, no, therefore here I max, what you can write it now, therefore root I plus root I by 2 whole square. So this is if it is like a 4 I naught, no, therefore it will be less than 4 I. Clear? So I minima, therefore root I minus root I by 2 whole square. So therefore it will be greater than 0, because it will not become to the 0 here. So that means what you can understand here, no, this dark fringe will not become like a completely dark, no, therefore bright fringe will be having less brightener. So both bright and dark fringe now will become darker now, right? This dark fringe now will not become like a darker, this is not correct, no. So dark fringe will become like a less dark, yes, this is less dark, no, bright fringe will become like a less bright. Okay, this is your correct answer. Clear? So now we will go for understood, no. Now you can we'll go for one more question. So in YDSE experiment, wavelength of light it is used, wavelength is given as 6000 Armstrong into 10 the power of minus 10, therefore 6 into 10 the power of minus 7 meters. Clear? The phase difference between the light waves reaching the 7th bright fringe from the central maximum, therefore is asking phase difference. So phase difference, therefore we can write it as like a 2 pi by lambda into path difference. Clear? So first let us calculate the path difference, no. Path difference for this one now, it is nothing but a n lambda. So n lambda is nothing but a phase difference between the light of waves reaching the 7th bright fringe, 7 lambda. Therefore here what you can write it now, so therefore here 7 lambda cancel now, 2 pi by lambda into 7 lambda cancel, therefore 14 pi will be your phase difference. Clear? So 14 pi radians. Okay. Now we'll go for another concept, no, another question. Okay, in YDSE, the fringe width is given as, okay, fringe width. So beta is given, beta how much, no, 0.2 mm. If the wavelength of the light is increased by 10% and the separation between the slits is increased by 10%, no, then therefore what is asking now, wavelength. So wavelength increased by 10%, no, therefore let us see here, no, initial wavelength is lambda. So final wavelength is nothing but a lambda plus 10 by 100 into lambda, 10% means what? So 11 lambda by 10. So this is your final lambda. Clear? Next, what is given now? And the so separation between the slits is, so d. So initial distance is d. So final distance is nothing but a d plus 10% of d. So that is nothing but a 11 d by 10. Clear? So new fringe width will be, new fringe width. So will be how much now? Therefore fringe width, what is the formula? Fringe width is new fringe width by old fringe width, no? So it is directly, see here, nothing but a d lambda by d. So d is not changing, no, capital D is not changing, no. So lambda only is changing. So directly proportional, therefore lambda dash by lambda. So it is inversely proportional, no. Therefore here d by t dash. Clear? So lambda dash by lambda. So therefore lambda dash is nothing but a 11 by 10. Therefore you can write it now into, so 10 by 11, therefore it will get cancelled out, no, it is 1. So beta dash will be equal to beta, therefore it is nothing but a 0.2 mm. There is no change will be in the fringe width. Fringe width will not change. Clear? So therefore now we'll go for another question. Right. Now a YDSE produces interference fringes, no, for the sodium light of wavelength, no, wavelength is given how much, no, 5890 Armstrong, 10 to the power of minus 10 meters. So right. So this is theta is given, angular fringe width, no, 0.4 degree apart. What is the angular fringe separation if the entire arrangement is immersed inside the water? Okay. So therefore here is asking, no. So therefore here what you can write it now? So theta, so is nothing but a angular fringe width, no, lambda by d. Clear? Clear? So therefore here lambda by d or beta by d also you can write it, no problem. Therefore this is for air, this is also for air. So theta for water divided by theta in air. So wavelength in water by wavelength in air. So this is nothing but a 1 by refractive index. Clear? So theta in water, so can be written as theta in air by its refractive index, no. Theta in air is how much now? 0.4 degree divided by 4 by 3 means, so this is 0.1. So 0.3 degree will be your answer. Clear? So simple one, no. Now we'll go for one more question. This is slightly important question, no. So in YDSE, intensity of light at a point on the screen whose path difference is lambda is k. So therefore intensity is given as k at what path difference is how much? No, it is nothing but a lambda. This is given. Lambda being is a wavelength is used. Find the intensity at a point where path difference is. So therefore delta dash is given as lambda by 4 is asking what is the intensity now. Clear? So therefore here, so in YDSE experiment no, therefore mostly we have to consider, so the slits of same intensity now. Therefore same size, slit sizes no, it will be not changed no, amplitudes are same, intensities are same. So in interference concept no, I already discussed if amplitudes are same and intensities are same no. So what will be the formula? Intensity is nothing but a 4I naught into cos square phi by 2. This is your intensity relation for our YDSE. So this formula we have to use on when intensities are same, amplitudes are same, or the slits are there, no, the slit sizes are same, right? So here path difference is given, no, he did not give any phase difference, no. Therefore first let us calculate the phase difference in this case, in this situation, no. What is the phase difference here now? Phase difference is nothing but a 2 pi by lambda into lambda. Clear? So this will get cancelled out now. Phase difference is 2 pi. New phase difference no. Therefore 2 pi by lambda into lambda by 4 get cancelled out now. Pi by 2. Clear? So therefore here I dash can be written as by I. So both the situations of same no. Therefore this is get cancelled out no. So cos square therefore phi by 2 I dash is nothing but a, so pi by 2 by that means pi by 4. So cos square therefore, so this is nothing but a 2 pi by, therefore it is 2. Clear? So therefore what I can write it now, this is nothing but a pi by 4 means 1 by root 2, 1 by root 2 whole square means 1 by 2 divided by right. So therefore this is pi means cos pi means nothing but a minus 1 whole square means nothing but a 1. So that implies intensity I dash will be equal to, so therefore I by 2 that is nothing but a k by 2 will be around, right. We'll go for one more question no? Okay. Okay, therefore here the concepts we are getting now, therefore here what we are going to write. So here a film of refractive index is 1.5 is introduced in front of the lower slit. Okay, the fourth maxima shift to the origin now, find the thickness of the plate now. Okay, so this type of concepts now some information is required now. Let us see this one now. See here one concept, right. This is very important now. In YDSE what we are going to do now, we are going to insert one glass slab or glass film or anything now. So what is going to happen now? See here, let us see, you can understand very clearly. So very interesting things no. Now therefore this is your screen. Now without anything no, therefore they are going to get here central maximum and everything no, you will get it now, right. Suppose in this one path no, suppose what you are going to do no, therefore in this one path, listen how to solve this type of problems no. So concept it should be very clear. So here this suppose S1 and S2, this is P. Suppose what I am going to do now, I am going to insert one glass film or glass slab something whose refractive index is n, whose thickness is t. Now due to this one, due to this glass one or any one glass, therefore what will happen now, it will undergo like a some shifting onto this one. Clear? So this light ray will be able to get shifted. So therefore now what is going to happen now, therefore due to this shift, therefore it will be comes to here. Now therefore here they are going to get shifted here now. Clear? Understand? Therefore in this way they are going to get shifted. So now we will get it as like one path difference. Now how to calculate the path difference? Very important, path difference. How to calculate it now? First of all, let us see. So this and also one more important. Suppose if you are going to insert the slit on the top side, therefore this central fringe, it will be shifted in the same direction of this one. And suppose if you are inserted downward, therefore it will be able to shift it downward only. Clear? And so due to inserting, therefore the fringe width will not change. Fringe width will be the same only by inserting the slit, or inserting the any one glass slab, so therefore glass plate, so therefore the fringe width we are not going to change anything. Clear? But only what is going to happen now, the central maximum will be shifted, all the fringes also will be shifted in the same direction. In which way we are going to keep it, in the direction only the fringes will be get shifted. Clear? Here very important is you have to calculate the path difference now. Path difference. How to calculate the path difference now? Listen carefully. So first path difference due to this in the air, therefore what will happen now? This is a p dash. So therefore S2p, right? So due to this one now in the air, so minus, therefore this is nothing but it is in the S1. This totally distance will not travel here, so S1p minus, right? So this much distance will not be travel in the air, therefore this is t. Clear? You understand? This is for the air. Clear? So now, and therefore if any slab it is placed, therefore the extra path difference, what you can write it now, n into t. Clear? So therefore plus n into t. Now like this you can write it now. Therefore what you will get it now, S2p minus S1p, so minus therefore n minus 1 into t. So therefore, or sometimes directly we can rewrite it as, so therefore, so this is because of due to in the air and this is due to in the slab onto this. Directly some path difference also we can rewrite it as sometimes, due to this one, extra path difference is nothing but n minus 1 into t. This much amount of change it is going to takes place now. Clear? So now you understand how to write it. This is for the air, this is for medium. Clear? You understand? Right? So this is the path difference. Suppose here now what we can write it now, suppose here where is a bright fringe and all this one, so you can rewrite it as path difference is nothing but n lambda, therefore path difference is nothing but 2n minus 1 into lambda by 2, so will be the path difference now. Clear? Now suppose how much amount of shift is taken place now. So this shift, this how much shift it is taken place now means what we want to calculate now. So this path difference, therefore it should be equal to 0 for the central maximum to this. So here this due to the air, we want to calculate it, therefore due to the air, again therefore this it will be a delta. So delta can be written as like a d sine theta. Therefore this is here, here so sine theta is equals to, so delta by d, or in terms of this one, therefore tan theta, so it will be equal to y by d. So therefore here delta by d is equals to y by d, so y by d, so therefore here anything, you can rewrite it as, so don't confuse here, right? So this is here extra path difference, what you can write it now, delta is equals to d sine theta, so I can rewrite it as, so here delta is equals to d sine theta minus n minus 1 into t. Suppose if you want to calculate this one, therefore here sine theta is nothing but a tan theta, so delta is equals to d into sine theta and tan theta both are same, d into y by d, so minus n minus 1 into t. So this is your path difference, so in terms of this position. Clear? Suppose only how much amount of central maxima is getting shifted here, no? So if I want to calculate central maxima shift, no, therefore delta will be equal to 0. So path difference will be equal to 0. So this also will be equal to 0. So dy by d is equals to n minus 1 into t. So y is equals to n minus 1 into d into t by d. So will be the distance. So this is your central maxima is this much amount of is getting shifted, this distance, no, therefore can be calculated. So therefore this distance sometimes, no, so they may ask you, so how many number of fringes will be get shifted, no, therefore here number of fringes, no, can be written as ycm divided by the fringe width, right. So why? Because the fringe width will not be the same, will be the same. So this in this distance how many fringes can be fit, no, that many number of fringes will be get shifted here, no, therefore you can rewrite it as anything, no. So this is your number of fringes will be shifted, this is the center of central maxima, central bright fringe will be shifted. So this is your path difference, this is a path difference, this is a path difference, no. Clear? So I think therefore you got the clarity in this one, no, right. So if the slit is placed here, now clear. Now suppose double slit is placed, now therefore how to write it now, double slit is placed, so we will write it now. So whenever there is a necessary is there, so we will do that concept. So now let us see our question now. Now what is given now, this is, so here in YDSE wavelength is given now this much and d is given now. When the film of refractive index is 1.5 is introduced in front of the lower slit, therefore this is 1. So this is your central maxima, no. Now in this one, no, therefore here there will be a shift is taken place now. Therefore what is going to happen now, this it will becomes like toward this side, this it will becomes toward this side. Clear? Right. So now he is asking find the thickness T. So lower means it will move downward, no, therefore and 4 maximas will be shifted, therefore from the origin, that means here there will be number of fringes is nothing but 4 maximas, 4 beta. So this is nothing but ycm, this is the shift. So I already discussed, no, in your previous concept, no. So this much amount of shift, no, therefore this it will be is nothing but n minus 1 into d into t by d. Clear? So 4 into, therefore beta is nothing but d lambda by d. So is nothing but n minus 1 into t into d by d. So d by d get cancel out, no. So that is nothing but 4 lambda is equals to n minus 1 into t. Clear? So thickness we want to calculate it, no, thickness of this one, no, 4 lambda, 4 into 6 into 10 to the power of minus 7 divided by 6000 Armstrong, no, divided by n minus 1, n is nothing but 1.5. So 1.5 means 0.5, 0.5 means 1 by 2, 1 by 2 means is nothing but 2, right. So this is 12, 12, 24, 24 into 2, 48, right. So 4.8 into 10 to the power of minus 7 meters. Clear? So this is our thickness of the film. Clear? Right. Here there is a not 4.8, no, it is 48, or we can write down 4.8 micrometer will be the thickness, right. Now let us go for one more question now. Right. So in YDSE wavelength of 400 nanometer is used when the thin film of refractive index is 1.5 and thickness is given, no, is placed in front of the upper one. Now find the number of maxima that cross the central line. See, that is what I told you, no, therefore this is one. So here it is there, no. Now therefore here it will be the, now what is given now, therefore he inserted here, no, therefore then what will happen now, then it will becomes to here somewhere, right? So here this is your YCM, shift in the center of mass, no? Therefore he gave refractive index and thickness, no? So he is asking how many number of fringes can be able to fit it, no? So number of fringes can be written as like a YCM by fringe width, no? So YCM already you know it, no? YCM is nothing but a, so n minus 1 into T into d lambda by d. Clear? So therefore here what you can write it now? This is what? dt by d. Yeah. Therefore here, so can be written as, therefore here also divided by this one, no? Therefore n minus 1 into T into d by d. So by d lambda by d. So d by d get cancelled out, no? So number of fringes can be written as, so n minus 1 into T by lambda. Clear? So don't confuse here n and n, no? This is, suppose I will take it as refractive index is mu. Refractive index is mu, here I can take it. Clear? So therefore here number of fringes, no? Therefore refractive index is 1.5 means, so 0.5 means 0.5 into thickness is given, thickness is how much, no? 4 micrometer, 4 into 10 the power of minus 6 divided by, therefore 400 nanometer 10 the power of minus 9, right? 4 means it is 100, so 10 the power of minus 7, so taken top, no? 0.5 into 10 the power of minus 6 into 10 the power of 7, that is nothing but a 5 fringes, no? We are going to get it. Clear? 5 fringes will be able to get shifted here, no? Clear? Now we will go for one more question, no? Okay. So what is given this question, no? Therefore in YDSE D is 1 millimeter and D is given, no? Therefore the slabs of thickness is T1 is 1 micrometer, T2 is of refractive index is 1.5 and 2 are introduced in upper and lower respectively such that the fringe pattern does not shift now. Okay. You know that, therefore here due to this one now, listen carefully. So here due to actually without anything, no, therefore it will be able to come to here. Clear? Now what happens now here? So there is a one slab is kept here now. What is the one slab now? Therefore here one slab, therefore here it will be thickness is given as 1 micrometer, so refractive index is given as 1.5. Therefore due to this one now what will happen now? This will be get shifted now, and one more slab is also kept in this one now. So therefore refractive index is 2 and thickness T2 we want to calculate. Due to this one now it will be shifted here now, due to this one it will be shifted upward. So due to this one is shifted upward, but due to this one it will be pulling downward onto this. Therefore, so finally the central maxima it will be kept at this point only. So YCM will be comes to the 0 only. So therefore due to this, suppose which one is creating more path difference now, therefore n minus 1, so into T, so therefore it is m minus 1 into T. So therefore here these two, this is shifting downward, this is shifting upward, no? So we know it, YCM is what, n minus 1 into T, no? Therefore, so what you can write it now? So this is nothing but a, so m minus 1 into T2 minus n minus 1 into T1. What is the formula here, no? Therefore YCM, so dt by d. This, therefore it is 0 means what you can write it now? So m minus 1 into T2 should be equal to n minus 1 into T1. Clear? So clearly you can solve this question, no? Therefore here this is m, I can take it as 2 minus 1 into T2 we want to calculate. So n is nothing but 1.5 means 0.5 into T1 is nothing but 1 micro. So T2 this is 1 now, therefore T2 should be equal to, here T2 should be equal to 0.5 micrometer. Clear? So which is dominating, no, therefore in that way it is going to get shifted, no. This is slightly important, clear, right? So go through it, no. So we'll see some more questions now. We'll see one more question, no. This is one of your JEE main question, no, right? So here I think if you are not visible, no problem. So just concentrate on my words, no. Suppose monochromatic light is there, no, of wavelength is given how much now? 500 nanometer it is given. So is used in Young's double slit experiment, no, an interference pattern is observed on the screen. One of the slit is covered with a very thin glass of refractive index is given now. Central maxima is shifted to the position previously occupied by the fourth fringe now. Therefore, number of fringes it is shifted, it is how much now? 4 beta. Therefore, 4 number of fringes are, it will be the 4, and YCM, right? So YCM it is nothing but a 4 beta. Therefore, refractive index is n minus 1, okay, into T into d by d, right? So 4 into d lambda by d, so is nothing but a, this is nothing but a refractive index. Let us take refractive index mu minus 1 into thickness into d by d. So these two cancel here, no. So therefore here thickness is nothing but we can write down 4 lambda by, so mu minus 1, 4 into lambda is nothing but a 500 nanometer 10 the power of minus 9 divided by, so mu value is how much now? 0.5. So 0.5 means is 1.5, 1.5 minus 1 means 0.5, 0.5 means nothing but 1 by 2. So therefore this I can write in 1000 means 4 into 10 the power of 3 into 10 the power of minus 9. So 4 into 10 the power of minus 6, 4 micrometer. So therefore answer will be 4 micrometer. Clear, right? So right. So thank you for watching. Please subscribe to my channel now, right? I hope you learned Young's double slit experiment very thoroughly. So go through the theory and go through the numericals now, so that you will get very good clarity in the Young's double slit experiment now. So if right, so in some other time now, therefore I will select some more questions now which are having the mixed concepts now, then we will do like a separate video now, right? So thank you. Please subscribe and share this video those who need the physics classes now.